Hi folks! In this part of Introduction to Modern Web Development, we are going to take a look at Git. Git is a version control system. Version control is a fancy way of saying managing changes to files or documents. Version control has been around for as long as people have been writing. When you look at a folder on a computer system and you see index.html and index2.html and index3.html, that's a kind of version control system, albeit a terrible one. Version control software is able to do a much better job of managing changes to files than we can generally do on our own. Git is a particular kind of version control software known as distributed version control software. Distributed version control means rather than a single central repository which you sync to, each person has an entire copy of the code base. So rather than checking out one file from a central repository and working on that file, you have an entire copy of the code base and you work on it locally. This makes common operations like committing changes much faster, and a side effect is you end up with multiple backups of your project. That is not a replacement for a good backup strategy, but you will find that handy from time to time. Git is by far and away the most popular version control system on the market right now. It's used from anything like tiny things that I do to the Linux kernel. And it's the common version control system for many online platforms like GitHub. I'm going to show you the very basics you'll need to get started with Git. There's a lot you can do with Git that I'm not going to cover, but the things I cover are things that you will definitely have to know how to do. So let's get started. First thing you're going to need to do is install Git. Git is available for Linux, Mac, and Windows. It's fairly straightforward to install. It may already be installed if you're on a Linux system. If not, it'll be in your repos for Mac and Windows. Just download the installer and install it. When you're done, you should be able to type git --version, and we'll come back with a reply that's the version of your installed Git. If you don't see this, something in the installation has gone wrong and you need to go back and figure that out before you go any further. Now there's two things you're going to need to do with a brand new installation of Git before you can get going. You have to tell Git who you are, or give it some user credentials. And these aren't credentials to log into a server or anything like that. These are just so when you make a commit to your code base, it knows who to attribute that code commit to, which is critical when you're working on a project with more than one person. So we need to add a username and an email address for that username. We're going to type git config and we're going to type --global. That means this is a global scope, so this will be applied by default to everything unless you specify something different in a local Git repository. We're going to user.name and put a double quote and whatever you want it to be there. Type enter. Now we're going to put in our email address, git config global user.email double quote. No spam, please. I don't think there's anybody in the world that doesn't have my email address, so not too worried about that. Now we're all set. Now it knows who to attribute commits to when you're making your commits. So we are ready to start gitting. Let's make a new folder. Git test, because I'm boring. And we have to tell Git that we're going to be tracking this folder and its contents as a repository. Git does not have a server-side component. Git is what you might call a pile of files database. That quote I heard a lot from the SQLite main developer. I don't think it was meant in a flattering way, but it's basically tracks changes through a file system. It creates a .git folder. So there's no server component running here at all. It's just interacting with this Git repository folder when we issue Git commands. We're going to go git init. That's all we need to do. It's initialized our repository. So See, it made this .git folder, which if you're on a Linux system by default will be hidden, but that's where it's tracking all of our Git stuff. So let's make a file. Make a text file. Ah, gosh, I'm terrible. I apologize. So now we have a text file that just says get ya because reasons. Now, my setup is a little fancy. I'm running a shell called ZSH, and one of the extensions for it detects changes that haven't been committed, which is why I see this little red X. You can set this up on Windows or Mac. On Windows, you could use Windows Subsystem for Linux, so you can see this kind of fancy stuff too. So now we've got a new file in this folder. Git status tells us what the status of the current working code is. It's going to tell us here that we've got nothing added to a commit, but we have an untracked file. By default, when you add a new file to a repository, it isn't being tracked by Git unless you tell it to. So we can go git add test.txt. Now we can go git status. We see that green text, and it's saying we have a new file. Before, if we'd done a commit, it actually wouldn't have committed anything because we have a file that's not being tracked, and that was the only change. So now we have a new file. Let's commit this change we've made to our master branch. Master branch is the default and only branch when you initialize a new repository. Now git commit will do the name of our file that's we just added, and we're going to do -m to write a message, and the message will be our first commit. So now our status is clean again. We go git status, we're all caught up. If we do git log, we'll see that that is our only commit to this repository. If we do git log -p, you'll still tell a little more information about the change in that particular commit. And we'll see where it'll even put the text that was in that file that we added. So we've made our first commit. We are really rolling here. So we've seen our commit, we've shown history. Let's make, say, another commit for fun so you can see that. We'll just go vim that file again. We'll just type in second commit. And we'll go git commit, the name of that file again, and the message will be second commit. Ideally, you want these messages to be extremely or descriptive of exactly what changed. So now I'm going to go git log -p. We'll see we have two commits in here and what those commits were. Yay! Yay us! Now, normally, you don't want to work on your master branch. Your master branch is where the latest and greatest deliverable code is, generally speaking. What you want to do is create a branch. A branch is like a copy of your master, or it can be another branch that you can use to make your changes and test, and then when you're ready, commit those back to master. Now to do that, we're going to go git checkout. Checkout is how you change between branches. We're going to do -b to make a new branch. We're going to say, call it my branch. So now we're actually in the my branch branch. You can see this on here because of my fancy ZSH. You can also type a git branch. It'll show you all of the branches on this repository, and the one you're currently on will have a star next to it. When you're in interactive code like this, like git log or git branch, to get out, you just hit Q for quit. Now I got a branch. Let's vim that file again. My first branch. So we can commit this, and when we commit this, it's committing to our branch, not to the master repository. first branch will be the message, and off it goes. Now to switch between branches, you do use git checkout. So I'm going to git checkout master to get back to the master branch. To merge what we just did with my branch into master, we'll go git merge the name of that branch. It's going to put that branch in. Now we can go git status. We're all good. Git log -p. We'll see that we have my first branch here. And there's our other commits. Now suppose we did something terrible. This has never happened to me. I've never committed a bad piece of code in my life. Actually, before we do that, if you're done with a branch, usually name your branch kind of like what feature you're working on. When you're done with a branch, you can delete it by going git branch -d for delete and the name of the branch. So now when you go git branch, you'll see we only have master now. Suppose you screwed up. It's never happened to me, but I know it happens to other people. And you want to roll back to a particular state. This would be the oh no moment. Well, if you go into git log, you'll see all your commits. These long strings here are the ID pointer for that commit. And say this first branch went terrible, we need to just toss this entirely. We can copy that long string, and we can go git reset -- hard, because we're serious here, and then the name of that commit. So now we're back on second commit, and if we look at that file, we'll see it doesn't have the contents that were dropped into that branch anymore. We've rolled back to that previous state. There are a lot of different ways to manage rolling back to different states and seeing what changed between states and rolling only particular files to different states. So there's a lot to investigate there when you run into these kind of problems, but that will get you back to the state of a particular commit. And here's a big tip for you. Make your commits small and specific. And I'm guilty of this quite a bit. I will make a commit that the message is like, I changed a bunch of stuff. There'll be like 20 different files that changed. That's generally not the way to do it. It makes it very hard to go back to different states in your code. What's better is if you make a particular change to a particular file, commit that file and make that a commit by itself, and with just exactly what you did to it. So if you got 10 changes to make 10 commits. That makes it easier to roll backward and forward in your Git history. So that is a quick introduction to Git and how to use it. It's really not bad. It's something that you should use on every software project you do. Even if it's just you working on the project, it will help you. I can't tell you the number of times using version control system like Git has bailed me out of things that I've done in the past. So that's an introduction to Git. Hope you enjoyed that, and we will have more in this series. Bye-bye.